Welcome to session 6 of PLSQL. It deals with writing explicit cursors. Let's come to the objectives of the session. In this lesson, you learn the difference between implicit and explicit cursors. You also learn when and why to use an explicit cursor. You may need to use a multiple row select statement in PLSQL to process many rows. To accomplish this, you declare and control explicit cursors. So after completing this lesson, you should be able to distinguish between an implicit and explicit cursor, discuss when and why to use an explicit cursor, use a PLSQL record variable, and write a cursor for the loop. Let's come to about cursors. Oracle Server uses work areas called private SQL areas to execute SQL statements and to store processing information. You can use PLSQL cursors to name a private SQL area and access its stored information. Cursors could be of implicit and explicit type. Implicit cursors are declared by PLSQL implicitly for all DML and PLSQL select statements, including queries that return only one row. Explicit cursors for queries that return more than one row. Explicit cursors are declared and named by the programmer and manipulated through specific statements in the block's executable action. Oracle Server implicitly opens a cursor to process each SQL statement not associated with an explicitly declared cursor. PLSQL also allows to refer to the most recent implicit cursor as SQL cursor. Let's come to explicit cursor functions. Use explicit cursors to individually process each row returned by a multiple row select statement. The set of rows returned by a multiple row query is called the active set. Its size is the number of rows that meet your search criteria. The diagram on the slide shows how an explicit cursor points to the current row in the active set. This allows your program to process the row one at a time. A PLSQL program opens a cursor, processes rows returned by a query, and then closes the cursor. The cursor marks the current position in the active set. Explicit cursor functions are: number 1, can process beyond the first row returned by the query row by row. Second, keep track of which row is currently being processed. And allow the programmer to manually control explicit cursors in the PLSQL block. Let's come to controlling explicit cursors. Now that you have a conceptual understanding of cursors, review the steps to use them. The syntax for each step can be found in the following pages further. First is declare the cursor by naming it and defining the structure of the query to be performed within it. Second, open the cursor. The open statement executes the query and binds any variable that are referenced. Rows identified by the query are called the active set and are now available for fetching. Number 3, fetch data from the cursor. In the flow diagram shown on the slide, after each fetch, you test the cursor for any existing row. If there are no more rows to process, then you must close the cursor. Number 4 is close the cursor. The close statement releases the active set of rows. It is now possible to reopen the cursor to establish a fresh and active set. You use the open, fetch, and close statements to control a cursor. Open statement executes the query associated with the cursor, identifies the result, and positions the cursor before the first row. Fetch a row. The fetch statement retrieves the current row and advances the cursor to the next row until either there are no more rows or until the specified condition is met. Close the cursor when the last row has been processed. The close statement disables the cursor. We now come to declaring the cursor. The syntax is cursor underscore name is select underscore statement. Use the cursor statement to declare an explicit cursor. You can reference variables within the query, but you must declare them before the cursor statement. In the above syntax, cursor underscore name is a PLSQL identifier. Select underscore statement is a select statement without an into clause. Note, do not include the into clause in the cursor declaration because it appears later in the fetch statement. The cursors can be any valid ANSI select statements to include joins and so on. Let's come to an example of declaring the cursor. In the example on the slide, we say declare cursor emp underscore cursor is select employee underscore id last name from employees. Cursor DPT underscore cursor is select star from departments where location underscore id equals 170 begin, and then we can fetch the values. The cursor emp underscore cursor is declared to retrieve the employee id and last name columns from the employees table. Similarly, the cursor DPT underscore cursor is declared to retrieve all the details for the department with location ID 170. We can declare the variables to store the values like declare v underscore emp number of type employees dot employee ID person type, v underscore ename of type employees dot last name person type. Then cursor emp cursor is select employee ID last name from employees. Then we can begin the cursor, select the values, and then store them in the variables which were declared. Fetching the values retrieved by the cursor into the variables declared in the declared section is covered later in the particular session. Now let's move on with opening the cursor or the open syntax. The open statement executes the query associated with the cursor, identifies the result set, and positions the cursor before the first row. The syntax is open cursor underscore name. In the syntax, cursor underscore name is the name of the previously declared cursor. Open is an executable statement that performs the following operations. Number 1, dynamically allocates memory for the context area that eventually contains crucial processing information. Number 2, parses the select statement. Number 3, binds the input variables, set the value for the input variables by obtaining their memory addresses. Number 4, identifies the active set, the set of rows that satisfy the search criteria. Rows in the active set are not retrieved into variables when the open statement is executed. Rather, the fetch statement retrieves the rows. Number 5, position the pointer just before the first row in the active set. For cursors declared using the for update clause, the open statement also locks those rows. The for update clause is discussed in the later lesson. Note, if the query returns no rows when the cursor is opened, PLSQL does not raise an exception. However, you can test the status of the cursor after the fetch using SQL %rowCount cursor attribute. We now move to fetching data from the cursor. The fetch statement retrieves the rows in the active set one at a time. After each fetch, the cursor advances to the next row in the active set. The syntax is fetch cursor underscore name into variable 1, variable 2 or record underscore name. In the syntax, cursor underscore name is the name of the previously declared cursor. Variable is an output variable to store the results. Record underscore name is the name of the record in which the retrieved data is stored. The record variable can be declared using the %row type attribute. Certain guidelines. Number 1. Include the same number of variables in the into clause of the fetch statement as columns in the select statement, and be sure that data types are compatible. Match each variable to correspond to the columns positionally. Alternatively, define a record for the cursor and reference the record in the fetch into clause. Test to see whether the cursor contains row. If a fetch acquires no values, there are no rows left to process in the active set and no errors is recorded. Note, the fetch statement performs the following operations. Number 1. Reads the data from the current row into the output PLSQL variable. Number 2. Advances the pointer to the next row in the identified set. Coming to an example of fetching data from the cursor, you use the fetch statement to retrieve the current row values into output variables. After the fetch, you can manipulate the data in the variables. For each column value retrieved or returned by the query associated with the cursor, there must be a corresponding variable in the into list. Also, their data types must be compatible. For example, retrieve the first 10 employees one by one. You can write down the cursor as set server output on declare v_emp number of type employees.employee id %type, v_ename of type employees.last name %type. Cursor emp_cursor is select employee id, last name from employees. Begin open emp_cursor for I in 1 to 10 loop. Fetch emp_cursor into v_emp number v_ename. Use dbms_output.put_line and print the value of empno with a space with v_ename, end loop, and then end the procedure.